Alright, so today we're going to do 3.4, solving exponential equations and logarithmic equations. So we're going to put together basically all that we've learned from Chapter 3 and then be able to solve any type of log or exponential equation that we're given. So two properties to keep in mind are the one-to-one property, and that says that if you have a base and it is the same and they're exponential, then their exponents have to be equal. Okay? If you have a log base A of x and that's equal to log base A of y, then those have to be equal, x and y as well. We talked about those before. The other property we talked about was the inverse property. It says that if you have log base A of x to the x, then this has to equal x. And if you have it in exponential form, so if you have a base of a to the log base a of x, then that also has to equal x. And if you don't remember the inverse property, you're just going to have to convert it between exponential and logarithmic form, just like you did on worksheet 1 yesterday. Okay, so those are the two properties that we just kind of need to remember. They help us to solve some of these things. So we're just going to do a bunch of examples today on how to solve. So we're going to solve for x, and then we also have to remember to check for extraneous solutions. All right, so let's start off kind of easy. So if I have 8 to the x equals 16. Here, you want to think about if it's in exponential form, can you make it so that you can use the one-to-one property? So is there a base for 8 and 16 that we can make match? So 8 I know is like 2 cubed. So this is the same as if I wrote 2 to the 3x. Then I want to see if I can make 16 match. So in this case, I can. 16 is 2 to the 4th power. So now I can apply that one-to-one property. I have a base of 2 for both of them, so I can just set those exponents equal to each other. So I have 3x equals 4, so therefore x equals 4/3. All right. Now let's say that you didn't recognize that. If you didn't recognize that you could make the bases match, then you could do the same thing that we were doing yesterday, which would be to change the base. So I'm in exponential form. I want to go to logarithmic form. So in order to do that, this is like option 2. So if I have that same problem, I can change this to logarithmic form. So if I follow this around, I have log base 8 of 16 equals x, and then I can just change the base using my calculator. So I have x equals log of 16 over the log of 8. And then if I was to type that into my calculator, I would again get x equals 4/3. So you get the same solution, just kind of a different approach to the problem. On the next quiz, you will not be able to use a graphing calculator. You will be able to use a non-graphing, but not a graphing. Okay. All right, so let's look at another one. So we have log base 5 of 2x equals 3. All right, so looking at this, I can apply the one-to-one property. There's really nothing else to do. I've isolated the log already. So at this point, I want to go ahead and convert. So I'm in log form. I'm going to convert it to exponential form. So this is going to give me 5 cubed equals 2x. So 5 cubed is 125, and then that's equal to 2x. So if I divide both sides by 2, I get x equals 125 over 2. Okay, so far so good. All right, see? Here I have 3 times 2 to the x equals 15. All right, so before you do anything, you always want to make sure that you isolate the exponential or the logarithmic piece of the function. So in order to do that, I should divide by 3 first. So I'm going to divide both sides by 3, and that gives me 2 to the x equals 5. So like A, if you go back up and look at A, you can't make these bases match. 2 and 5, there's nothing that you can do to make those bases match. So in this case, you're going to have to use the approach of changing it to the log form. So in order to do that, you make this base your new base. So log base 2 of 5 equals x. Log base 2 of 5 you can't evaluate in your head, so you're going to have to change it to be able to enter into your calculator. So you're going to have to use that change of base formula. So here this would be x equals log of 5 over the log of 2. Now this is called your algebraic solution. It's basically the solution you would type into your calculator. Once you type this into your calculator, so if I type in the log of 5 divided by the log of 2, I get this numeric solution of 2.322, which will round to the thousandth place. And this then is called your numeric solution. And I'll ask you for both on the quiz. All right, let's move on. You have the natural log of x minus the natural log of 3 equals 0. All right, so here you've kind of have your logs isolated. You could combine them, all right? So you could condense them into a single logarithm. But what I notice is that I have 2 logarithms and I can move one to the other side and therefore be able to use the one-to-one property. So that's what I'm going to do. I'm going to add over the natural log of 3. So I have the natural log of x equals the natural log of 3. And then I can apply that one-to-one property, giving me x equals 3. Okay. I guess we're on e. So I have 3e to the 2x equals 45. All right, so now in order to do this one, we're going to do the same thing. We're going to try to isolate the exponent first, which in this case I have to divide by the 3. That gives me e to the 2x equals 15. And then I can't solve it in my head, so I'm going to have to change it to log form. So remember that that log base e is the same as natural log. So I'm going to write that log base e first, though, of 15 equals 2x. So log base e is the same as natural log of 15 equals 2x. And then you would just divide by the 2. So I would get x equals the natural log of 15 over 2. So again, this would be considered your algebraic solution. And then when you actually typed it into the calculator to evaluate, you would get your approximate solution, which is the 1.354. And that is called your numeric solution. All right, let's do another one. So f, we have 5 times 2 to the t plus 3 minus 6 equals 10. All right, so for this problem, you're going to try to isolate the exponential. So I'm going to add the 6. So I have 5 times 2 to the t plus 3 equals 16. So at that point, I'm going to want to divide by 5. So I have 16 over 5. I can't change the base to match, so I'm going to have to convert it to log form. So this is going to give me log base 2 of 16 over 5 equals t plus 3. And then finally, I'm going to want to subtract the 3. So I have log base 2 of 16 over 5 minus 3. All right, now, some of you have a calculator that allows you to just change the base by typing it in. So if you had that, you could just type this all in right into your calculator. Just make sure you put parentheses around the 16 over 5. If you have to change the base manually in the calculator, then you would just have log of 16 over 5. Again, you want that in parentheses, divided by the log of 2 minus 3. And then you want to type that in. And if I were you, I'd make sure that I could type these in. I know I'm giving you the answers now, but I would type them into my calculator to make sure I could get those final solutions. All right, let's look at something a little different. Okay, so we have e to the 2x minus 3 e to the x plus 2 equals 0. All right, now this is a little different. It looks a little intimidating, but I want you to think about what this kind of reminds you of. Does it remind you of this? X squared minus 3x plus 2 equals 0. Hopefully it does. So that's what I think about when I see that. So right away I see a trinomial and I have to factor it. So I'm going to factor this, and then I want to think about what is e to the 2x? Well, I can break that down into two pieces of e to the x times e to the x, which would give me e to the 2x when I multiplied. And then you just factor it like normal. So this is going to give you minus 2 and minus 1. And to check it, you would get a negative 2 e to the x minus 1 e to the x, combining to negative 3 e to the x. So we're good there. So I'm not quite done. You have to then use the zero product property. So I'm going to set each one of those pieces equal to 0. Oops, minus 1 equals 0. And then I'm going to start solving. So I have e to the x equals 2 and e to the x equals 1. You can't do those in your head. So in order to do that, you're going to have to convert it to natural log. So when I convert it, I have the natural log of 2 equals x. Remember that natural log is the same as log base e. So you can think of it like log base e of 1 equals x, and then change it to natural log if you want. So you get the natural log of 1 and the natural log of 2. So x is going to equal 0 and 0.693. All right. H, you have 6 plus 3 times the natural log of x equals 2. All right, so this one's a little bit easier. You subtract the 6, gives you negative 4, and then you divide by 3, and you get the natural log of x equals negative 4/3. At that point, you're going to need to convert. So remember that this is like log base e of x equals negative 4/3. So in order to convert, you just change it to exponential form. So e to the negative 4/3 equals x, and then just put that in your calculator, giving you 0.264. All right, hopefully you're doing okay. Remember that this video is on the website, so you can always go back and reference it if you need to see it again. Okay, going through the alphabet. So you have 2 log base 6 of 4x equals 5. All right, so the first thing I want to do is I want to divide by the 2. If I divide by the 2 first, then it's going to give me a fraction. So I'd have 5 over 2. It'll work out fine in the end, but it's just going to look a little bit uglier. What you might want to do instead, and that's what I'm going to do, is pull this 2 over as your exponent. So that has to go to both the 4 and the x. So when I pull that over, I should end up with log base 6 of 16x squared equals 5. So I've kind of gotten around having to have that fraction there. All right, so then the next thing that you want to do is you want to convert it. You're going to have to convert it to exponential form. So to do that, you're going to have 6 to the 5th equals 16x squared. Then you want to divide by 16. So 6 to the 5th divided by 16 gives us 486. And then you have to take the square root. So now when you take the square root, remember when you're solving for x, you end up getting plus and minus 22.045. Now here's the issue. If I plug in that negative, I'm going to get undefined, right? It's the domain has to be greater than 0. So that means that this negative solution is extraneous. So the only solution I end up with is 22.045. So when I'm saying check for extraneous solutions, that's what I'm talking about, okay? All right, let's look at this next one. So I have log of x plus the log of x minus 2 equals 1. So yesterday you learned how to condense. So you do have to condense with these problems. In order to do that, you just follow those properties that we learned yesterday. So addition is going to convert into multiplication, division will convert into subtraction, and so on. Okay, so this addition is going to convert into multiplication. All right, giving me this. At that point, you can then change it to exponential form. So right now, this is like log base 10. So this is going to give me 10 to the 1 equals x times x minus 2. And then you're going to want to distribute. So this is going to give you 10 equals x squared minus 2x. I have to bring over the 10. So this is going to be x squared minus 2x minus 10 equals 0. And then the hope is that it factors. However, it does not, so you could either use the quadratic formula or you could complete the square. I'm hoping that at this point your choice is always to complete the square because it's better, faster, easier. All right, so in order to do that, you have to scoot over the c term, which is that negative 10, right? We already have a coefficient of 1 for x, so half of negative 2 is a negative 1. We're going to square it. So I'm squaring a negative 1, giving me a 1 on the inside. If I'm adding a 1 here, I have to subtract a 1 here. So I get x minus 1 squared minus 11 equals 0. I then have to add over the 11. And then I have to take the square root. So I get x minus 1 equals plus or minus the square root of 11. And then I have to add over the 1. So 1 plus or minus the square root of 11. Now, the square root of 11 is greater than 1, so when you plug in this negative, again, you're going to get an undefined solution here. So my only solution that's going to work is 1 plus the square root of 11. Moving on. So k, we have log base 3 of x plus the log base 3 of x squared minus 8 equals the log base 3 of 8x. All right, so what I'm noticing here is I have log base 3 all along. So I'm guessing I'm going to have to condense these. So that's what I'm going to try to do first, and then I'm going to try to apply the one-to-one property. So addition can be combined through multiplication. So I have x times x squared minus 8 equals log base 3 of 8x. And then I have log base 3 on both sides, so I can apply the one-to-one property, and those cancel, leaving me with x times x squared minus 8 equals 8x. If I distribute, I get x cubed minus 8x equals 8x. And then you don't want to add over the 8x. You have to subtract over the 8x and set this equal to 0. So you have x cubed minus 16x equals 0. And then you want to factor it. So we're going to factor out the x, giving me x squared minus 16. That's a difference of perfect squares, so this factors to x times x plus 4 times x minus 4. So I get the solutions of 0, negative 4, and 4. However, if I plug those in, I know I can't take the log of 0, so the 0 is extraneous. If I plug in a -4 here or here, I'm going to get a negative solution, so that's going to be extraneous. And then I just want to double check the 4. That would be positive, that would be positive, that would be positive, so that should work. So x equals 4. All right, one more. Remind me to do the difficult problem with you when I come back. So let's do this one. 300 over 1 plus e to the negative x equals 200. All right, so right now what I'm thinking is, first of all, I want to put this over 1. When I do that, I create a proportion, and I can cross multiply. So I have 300 times 1, which is 300, and then 200 times this gives me 200 plus 200 e to the negative x. I can subtract over the 200, and then I can divide by the 200, giving me 1/2 equals e to the negative x. And then I can convert. So now I got to convert to natural log. So I have the log base e of 1/2 equals negative x, or the natural log of 1/2 equals negative x. Divide by the -1, and I get negative natural log of 1/2. And then when you put that in your calculator, that gives you 0.693. All right. Hopefully that made a lot of sense to you, and that's pretty much solving logarithmic and exponential equations. So your homework tonight is 3.4, and then we'll have a work day when I get back. Okay.